Hello friends. So in today's lecture, we are going to see the numerical method bisection method. So bisection method we are using in the numerical methods. So in the few previous lectures that we have developed the code in the Matlab related to some basic matrices and all. So that was all the introductory part. Now for the specific any method how we can be able to develop the program. So in the today's lecture we are going to see the bisection method, and in the first part of this particular lecture, first of all we will understand what is the bisection method, how basically or we can be able to say theoretically this particular method is used, and then we are just going to complete the programming by using the Matlab. So first of all, what is the bisection method? So for the non-linear kind of that equation, when we are equating any kind of that equation to the zero, so these are the two non-linear equations you can be able to see in this on this particular screen. So this is actually the non-linear algebraic equation. So here you can be able to see that this particular first equation is equating with the 0, and in the second equation here you can be able to see that so this particular equation is equated with the 10. So this particular 10 we have to take to the left side, and again we have to equate this particular equation with the 0. Now this is the non-linear transcendental equations. So where some sort of the trigonometric part or some sort of that basically logarithmic part that has been comes. So these equations again we are equating with the 0. So such kind of that equation we can be able to solve its root by using the bisection method. So basically what is this particular theoretical part of this method, that first of all we will see that. So here you can be able to see one equation, that is this particular equation we are going to solve with this bisection method. So initially what we are doing, so first of all we are trying to identifying that particular roots where the particular sign of that particular function is going to be unchanged. Now here if we put in this particular equation 0 for the x, then we are getting the value for function is 3. Now when we are putting the value of minus 1, we are getting the 7.5, minus 2, 12.5. So all these three particular x elements are having the positive sign. Now this sign is getting changed when we are putting the x value in this equation as an 1. So once we will put the value of x as an 1, then we will get the value is minus 1 for the function. So here you can be able to observe that this particular function is changing its sign from positive to negative. So here we are interested in the sign itself. Now what is the next, that after getting this particular part when sign changing, so for the 0 and 1 we are getting the sign change. So we will just take this 0 as an a left side root and 1 as an a right side root, and once you will put that value for left and right side roots in this particular formula, and once you will, then your first iteration will be gets completed. So 0 plus 1 divided by 2, so this is the formula, that is a plus b. We will consider that left side root as an a and right side root as an b. So this particular P1 means first iteration we will get 0 plus 1 divided by 2 is equal to 0.5, and once again if we will put the value of that particular P1 into the function, then we will get the again the positive value. So if again we are getting the positive value, then we have to replace this 0 with a 0.5. So that now the next roots will be lies between 0.5 and 1, and so on. In this way we are just going to solve this particular part. Now here what exactly we are doing in this root bracketing criteria, so just try to understand. So this is the one figure I have drawn. So here what is our condition, just try to understand this. So the function either that f of a or f of b, if f of a should be less than 0, then definitely that f of b should be greater than 0, because one particular part has to be in the negative and one has to be in the positive, or vice versa situation. If f of a means function at the value of a, if it is greater than 0 means if it is positive, then our next part of the function, that is f of b, means once we'll put the value of b in the function, that should be a negative. So when we are just multiplying this f of a into f of b, definitely we are getting the sign as a negative, means the value will be less than 0. So here we can be able to see this one particular diagram where you will get the idea about it. If f of b is 0, then this will be a particular curve where we are getting the f of a, it is negative. If f of a is positive, then here we will get the f of b is negative. And these are the two roots, that is a and b, where we are getting the sign change of the function. When this particular root will be cut onto this particular line, then we will get the next root. So that's c. So we have to check the function for this value of c. After putting the value of this c into the function, if we will get the particular function as a positive, then we have to replace the previous positive value. If we are getting the value of function is negative, then we have to replace this previous negative value. So this is actually the bisection method, that is already we have discussed this particular part. So once again we will just take the look. If P1 we have to first of all identify, means first iteration. So after finding out the first iteration, if the first iteration means f of after putting that P1 into the function, if f of P1 into f of a, if it is less than 0, then definitely that value for P1 means after putting that value of P1 into the function, your function is positive. So we have to replace the previous positive value, means we have to replace this b with a P1. Similarly, we have to check if the function we are having getting the as a negative, means after putting the value of P1, if the value for function is negative, then we have to replace, means f of P1 into f of b. If it is less than 0, then we have to replace the previous negative with a next negative, means P1. Okay, so P1 will be gets replaced with this a, and then we will get the next root. Either it will be a P2, then so on, P3, P4, likewise. So here in this figure you will get the idea about it. Now basically for this particular part we have to develop the code. Okay, now how to develop this particular program into the Matlab, that is the important part. Now first, while developing the first part of this, here we will just give the name as a bisection method while developing the program. Now here you can be able to observe that when we want to give some sort of that writing where that should not be effect on that particular coding, we have to use this percentage sign. So once you will put anything into the percentage, that indicates there is some sort of that particular lettering, but there is no any effect on your particular coding. So here you can be able to observe that this particular method might be for a bisection method, but this writing will not be effect on the actual part of the coding. So anything in terms of instructions, if you want to write something, you have to write those things in terms of percentage in this Matlab coding. Now again, few things we are required, and that is we are called as an ingredients part. What is the meaning of ingredients? So ingredients means some sort of that raw material we are required. Now raw material, here we don't require any material, but actually raw material in terms of some sort of that inputs. So that user has to be provided that inputs, and those inputs we will write in this coding. Now first input in terms of what we are required while developing the code of the Matlab, so that is we are required the function. So we will just write this is as an f, and when we want to ask in terms of that particular part, we have to write as an input and then use the brackets. So semicolon input. Now we have to ask the user to put his function. So enter your function and complete the semicolon part. Now here we don't want to see that particular function in command, so that's why we will use the again the semicolon part. Now this is the first. Then what user has to be provided? Then he has to be provide the left and right side roots to us. So once again I will write as an input, then enter left side root, then similarly we are required the right side root as well, input. So have we got the idea now? What is the left side root and what is the right side root? Left side root means in the sense what? Where the function is having either maybe a positive or negative, and then it has to be supposed to be do its sign change. So enter right side root. And then we have to ask about the accuracy or tolerance, how much tolerance that user is required. So here enter your tolerance. It is actually not basically needed for basic program. Now here two conditions we have seen. Now here why this particular error is generated, we have to use the semicolon, otherwise this particular part will be gets reflected in the command window. Now you can be able to observe. Now this particular part that we have seen into this PPT, that first target is that now we have just completed the whatever may be the function that user is required. So he needs to be put that particular function, then he have to provide us that sign part, that is means initial root 0 and 1 where the actual sign change is happening in the function, and afterwards we have to complete these iterations. Now while completing these iterations, two conditions will be there. So for that purpose we have to go for the looping, means we have to check the condition. Now what are those conditions? Based on that condition we have to replace something by using this particular Matlab. Now once again just understand this particular part initially. So what we have did in this, so this is actually the sign change we are required. Now while developing the Matlab coding, the first part in the Matlab coding, that first of all we have to ask the user for its function, then that user has to be provide the function to us, and after giving the function, one more part is we have to ask to the user how many number of iterations he needs to be perform. So we will just take that as a capital N, that is input, because how many number of iterations, enter the number of iterations. So he is having the liberty, he can be able to perform 10 iterations, 20 iterations, 30 iterations, 100 kind of that iteration. Now first condition is like that. Here we have to check the condition first, means suppose we are having actually the two conditions. If f of a, means after putting the valid a part into f of b, if this particular condition, in this particular condition, if it is less than 0, then only our loop has to be initiated. Otherwise, if this condition gets failed, we have to come out from this particular program. Okay, so if this is happening, means if f of a is less than f of b, if it is happening, then only we have to enter into the loop. Okay, now for this particular purpose, how many iterations? Now in the iteration we have just asked that particular part, that is for first iteration and second iteration. So this again in the for loop we have to initiate the iterations. So we will just give that variable as an I. So it has to be initiated from first iteration and it has to be end with the last iteration. So this loop has to be there. If f of a into f of b, if this condition is fulfilled, then only we have to enter into this that particular loop. Otherwise, this particular loop I am going to be end, making the end, and this if loop I am also making the end. In between that we will write the program. If it is not happening, else okay, else display, what we have to get the display, you have entered invalid roots. Okay, if the roots are wrong, then we need to be get this particular part display onto the screen. Okay, means if this condition is not satisfying, means after if you are putting the a and b, if a into b is greater than 0, if it is not less than 0, then that particular part will be shown as an invalid root, and this if loop we are going to be end here. Now whether you have understood, once again I will explain this particular part. We have initiated with this if loop, means this condition, if f of a into f of b, if it is less than 0, then if this condition satisfies, then our Matlab algorithm that has to be entered into this for loop, and for loop we have to perform the number of iterations. That is, that iteration will be, for the iteration purpose we have defined this variable as an I. You can be able to take or define any kind of that variable. It is not required you have to take that I later only. Okay, now if this iteration, for the first iteration we have defined one more variable, that is as an C. What is this C? C is equal to, in bracket I will put that a plus b divided by 2. Okay, a plus b divided by 2. So simply it has to be check this particular condition, a plus b divided by 2. Now one more part that we have to take care into the last part that we have to see in that in this. Now here if c, value of c, if it is negative, okay, value of c is negative, just imagine, well here we have just shown that a is negative, b is, a is positive, b is negative. Here if the value of c, the condition might have been generated, the c either it may be a positive, either it may be a negative. Okay, now here in the next part, a might be a negative, b might be a positive. So here for both these cases we have to check the condition of c. Okay, now just imagine the value for c, means value for the first condition, if a is positive and if c is negative. Okay, so we have to check this condition. Okay, so once again we will put that if f of a into f of c, if this is negative, means if it is less than 0, then what we need to be replaced? What we need to be replaced means we have to replace this b with a c. So this part we have to include. We have to replace b with a c. Okay. Then one more condition. So that condition we will write in terms of else if. Else if it is not happening, then check else if f of b into f of c, if it is negative. Means what? Here you can be able to understand. F of b means a is suppose negative, then c has to be replaced with this a, b into c, then c has to be replaced, means a has to be replaced with this c. Okay, and that's all. So this is actually we need to be checked. Now this whatever with the if loop we have written, that we have to end. Now just check this particular if loop it is getting end over here, this for loop it is getting end over here, this if loop it is getting end over here. Now this is all about. Now we have to save this particular program. We will write as a bisection 4. Okay, then this particular program will get saved, and now we have to run this particular program. Now here it is asking that user to enter the function. Now I will just write down the function at the rate. How to write the function? That particular part we have seen in the last lecture, at the rate x. Okay, now here we are having the function 2 raised to x minus 5 into x plus 2. We have taken as an sample. Now initial root, that is 0, then 1. Okay, and tolerance we will take that 0.001 up to 4 digit iteration 30. Now here you can be able to see that nothing is performed. Now why it has happened? Here we have written all that particular programming part, but for the printing purpose we have to write something, then only means program is okay, but this particular in the part we have not shown any kind of that display. So for that purpose here we have to write fprintf. So fprintf command, so what particular part we need to be get display. So just we will consider that we are required to get display the iteration in terms of x, x1, x2 likewise. So x%d. Okay, this %d in the sense when we are writing any value in terms of floats or integers. So when we are required the integer 1, 2, 3 likewise, so we have to write down as a %. Now for this x, this will be gets x1, 2. So what iterations we have just shown? So 1, 2, 3. This loop will be gets repeated until this number of iterations will be performed. And in the next part, what we need to be get display, that is %0.4f/n, that is on the new line, and this will be complete the loop. And for the first this %d, what it need to be indicate %d, this has to be indicate this I means number of iteration 1, 2, 3 likewise. And the next part of this %.4f, what it should be gets indicated, that is as a C. So just take care whether you are using this C as a small, then here you have to also use this value of is as a small. Okay, now here almost we have completed the all program part. Okay, now here once again we will save this and then we will run this. Now here once again it is asking the function. I will write down the function. Then first root is 0, next is 1. I am required 0.001, iterations 30. Okay, so there is a little bit and showing that error. Okay, sorry sir, here you have to write fprintf. So I have just written this fprint only. So fprintf. Now once again we will save this. We will just clear this previous part, and now once again we will run this. Okay, one, then and 30, suppose 30 iteration. Now here you can be able to see that you are getting the answer for this. For first iteration 0.5, second 0.75, likewise it has been. Now from this 17 iteration onwards you will get the almost, or we can be able to say from 12 to 13 iterations we are getting the same kind of that value. Now again we can be able to use some looping part just to one more looping part just to break this, but for the basic purpose this particular part is sufficient for today's lecture. In the next lecture we are going to see the different particular parts. Okay, so thank you.